All right, let's take a little trip. We're heading out into the cosmos, to a place so ancient it's almost hard to wrap your head around. Astronomers just picked up this faint, rhythmic echo coming from one of the oldest cities in our universe. And you know what? It's telling us a story we really weren't expecting.
So take a look at this. It's a true metropolis of stars. And hidden inside that incredible swarm of light are six of the most precise clocks you could ever imagine. Pulsars. Now, we already knew about five of them, but today we're going to talk about that moment scientists heard the tiny tick-tock of a brand new one.
So, where in the universe are we? Well, we're looking toward the constellation Hercules, at this glittering ball of stars called Messier 13, or just M13 for short. And this isn't just any old star cluster. It's one of the brightest and most famous landmarks in the night sky. Okay, so let's get a sense of scale here. I want you to imagine a city with hundreds of thousands of residents. All of them are billions of years old, and they're all crammed into this tight, spherical neighborhood. That's a globular cluster. They're ancient, they're dense, and they are the absolute perfect cosmic factories for creating some really exotic stuff.
But how on earth do you find one special thing inside a place that's so incredibly crowded? Well, you don't look, you listen. You listen for a very, very particular kind of cosmic heartbeat, a signal from something we call a cosmic lighthouse.
And that heartbeat, it comes from a pulsar. So what is a pulsar? Well, it's the core that gets left behind after a giant star goes supernova. It's an object of just incredible extremes. We're talking about a sphere the size of a city that has more mass than our sun, and it's spinning hundreds of times every single second.
So how do we actually find them? Well, like a lighthouse, a pulsar shoots out these beams of radiation from its poles. And as it spins, that beam sweeps across space. If we happen to be in its path, our radio telescopes pick up a pulse of radio waves with every single rotation. Tick, tick, tick. It's unbelievably fast and unbelievably precise. Now, to hear these tiny whispers from all the way across the galaxy, you need a seriously colossal ear. And this is it. The 500-meter aperture spherical radio telescope, or FAST. It's this massive dish built right into the landscape, designed for one main purpose: to capture these faint, rhythmic signals from deep space. So, with this incredibly powerful tool pointed straight at M13, a team of astronomers started the very painstaking process of just listening, hoping to pull a brand new signal out of all that cosmic static.
And let me tell you, this was not easy. You have to collect just massive amounts of data and then run it through some really sophisticated software to hunt for that one repeating pattern, that one faint lighthouse beam that's hidden in an entire ocean of random noise.
So after all that searching, after all that work, what did they find?
This, right here. This is the eureka moment. This plot is the very first glimpse of the sixth pulsar in M13, which they've nicknamed M13A-F. You can see that repeating pulse, a clear signal that stands out. It's basically the first hello from a newly discovered ghost of a star. So let's get to know our new cosmic neighbor, shall we? M13F is an absolute speed demon. It spins more than 330 times every second. And it's not alone. It's locked in this gravitational dance with a companion star, orbiting it every 1.4 days. This officially makes it the sixth member of M13's very exclusive Pulsar Club. And you know, the discovery of M13F isn't just about adding one more number to the list. It actually helps us paint a much more complete family portrait of all the pulsars that are living inside this ancient city. So here's the whole family. You've got the loners, A and C. They're isolated. Then you've got the four that are in pairs, or binaries, B, D, E, and of course our newcomer, F. And just look at their spin periods. They're all measured in milliseconds. These things are spinning unbelievably fast. Oh, and see M13E? That one's a Black Widow pulsar, which means it's literally destroying its companion star. Yikes. Now, let's look at where they actually live. The circles here mark the very center of the cluster, the core, and then a boundary a bit further out. A couple of them, like D and E, are right there in the busy downtown area. But others, like B and our new friend F, live out in the suburbs. And as we're about to find out, their address matters a lot. And these aren't just names on a list, you know. Each one of these pulsars has its own unique radio signature, its own distinct heartbeat. You can see right here how different the signal from M13A looks compared to M13F.
Each one is like its own unique cosmic instrument.
So, the discovery of M13F and studying its whole family ended up uncovering a really strange secret about their home. For a place that we always thought was this chaotic stellar pinball machine, M13 is, well, it's surprisingly calm. Okay, to get this, we just need one quick concept: orbital eccentricity. Don't worry, it's simple. It's just a number that tells you how much an orbit is stretched out, away from being a perfect circle. An eccentricity of 0 is a perfect circle. The closer the number gets to 1, the more stretched out and oval-shaped it is. Now, look at this graph. This right here is the punchline of the whole discovery. The blue triangles, those are binary pulsars and other globular clusters. And you can see their orbits are all over the map. Many are really eccentric, really stretched out. But look at the red squares. Those are our pulsars in M13. They're all clustered right at the very bottom, which means their orbits are incredibly close to being perfect circles.
So what on earth does that mean? Well, in a typical dense cluster, stars are constantly getting knocked around by close encounters with other stars. All that gravitational jostling throws these binary systems into wild elliptical orbits. But in M13, the pulsars have these beautiful, nearly circular orbits. And that tells us something huge. They haven't been disturbed. They've been evolving in a strangely peaceful environment, completely untouched by the chaos we expected to find. And that's the big reveal. It turns out M13 has a very low stellar encounter rate. The stars in this city just aren't constantly bumping into each other. This discovery completely challenges our assumptions about what life is like inside these ancient star cities. M13 isn't the chaotic metropolis we thought all globular clusters were. It's more like a quiet stellar suburb where its binary systems can just evolve in peace.
You see, finding M13F didn't just add another number to a list. It helped us understand the true character of its home. And that leaves us with one last thought. In this incredible city of hundreds of thousands of ancient stars, how many more of these cosmic clocks are still out there, ticking away, just waiting to tell us their own strange secrets about our universe?